Hello viewers, welcome to my channel. I still remain your mathematics teacher, Mr. Maths&Phy Ephraim. Today we shall be discussing on the topic angles on parallel lines. This topic will help us to address other aspects of mathematics such as angles of elevation and depression, and even the topic bearing. Please don't forget to click on the subscribe button so that you'll be able to get the notifications of the subsequent videos in this channel. So let's get started with the topic angles on parallel lines. When do we say that two lines are parallel to each other? If you have a line like this, then another line. Okay, so we say that these two lines are parallel to each other if they are of the same distance apart, meaning that if we continue to draw them, they will never meet each other ad infinitum. So those two lines are said to be parallel to each other. But if you have two lines like this, then you have another line. These two lines are not parallel to each other. Why? Because if I should continue to draw them, they will have a meeting point. So therefore, these two lines are not parallel to each other. So two parallel lines are the two lines that are of the same distance apart and can never meet each other ad infinitum if you continue to draw them. So we normally use this indicator to show that the two lines are parallel to each other. Talking about line AB and line CD. We say that line AB is parallel to line CD. We normally write it this way. That's AB is parallel to line CD. I believe you must have seen something like this in mathematics, which means line AB is parallel to line what? CD. So that's how we write it in mathematics. Now let's get back to our question. We say that line AB is parallel to line CD. The line that is being drawn across the two parallel lines is called the transversal line. We call it the transversal line. Transversal. You can have more than one transversal line in two parallel lines. All right, so we call this line transversal line. So our intention here is to address some other components of angles which we call the corresponding angles, the alternate angles, and the vertically opposite angles. And recall that when you have two parallel lines and a transversal line is drawn across the two of them, 8 angles are produced. As you can see, angle A, angle B, angle C, angle D, angle E, angle F, angle G, and angle H. So 8 angles are produced. How do we now address it in terms of which one is corresponding to each other, or which one is alternate to each other, or which one is vertically opposite to one another? So we shall be looking at the corresponding angle to A, corresponding angle to B, corresponding angle to C, and corresponding angle to D. So you have to pay closer attention because this particular one here, alternate angles, you'll be applying it in angles of elevation and depression, as well as bearing. So this one is very, very crucial to those topics. That's why I said this particular topic is very, very important for you to understand. Now, going back to our question, the first one we have here is corresponding angles. For two angles to correspond to one another, as you can see the transversal line, they must exist at the same side of the transversal line. They must exist at the same side of the transversal line. All right, so let's get started with this. Corresponding angle. Another name I call corresponding angle is F angle. Letter F. I call it the F angle. What I do here is that I'll have to produce F from what I have here. How do I produce F? I can design this to look like F. Believe you can see what I'm doing. to produce F here. Let's try and produce F. Okay. You can see that it looks quite like F. Okay, and this F has two hands, this and this. So to get the corresponding angle after producing your F, but you must not do this in your questions. Once you understand it from this channel, you don't need to be drawing lines whenever you're solving questions. So by producing this F here, what we do to get the corresponding angle is, we say below this hand, you can see below the first hand is this, and below the next hand is this, right? So below the hand of this F is what? D. And below the hand of this particular one is what? H. So I can say that angle D and angle H are corresponding to each other. That's below the hand, below the hand. So D is equal to what? H. D is equal to H. D is equal to H. And we said that corresponding angles are equal. Corresponding angles are equal. Meaning that if I have 50 here as my D, 50 degree here. So what do you think H will be? Of course, H will still be what? 50 degree, because they are corresponding angles. And corresponding angles are equal. Now, still following our F. From this our F, above the hand and above the hand are corresponding to each other. Above the hand of this F here is B. Then above the hand of this particular one here is what? F. Okay, so we can say that above the hand B, above the hand here what? F. So I can say that B is equal to F. So that is to say the two angles are corresponding to one another. Let's look out for other corresponding angles. Let's get to this side. If you do the same thing by having 7, just like the way we had F, by having 7 here, okay, it looks quite like this. There's still the same idea. Below the hand are equal. So therefore I can say that C is equal to G. C is equal to G. Then going by the other one, above the hand here is A, above the hand here is what? E. So we can say that A is equal to E. So these are called corresponding angles, and we know that corresponding angles are equal. So I can say that A is equal to E, B is equal to F, C is equal to G, D is equal to H. They are called corresponding angles. Now let's get to the next one, which is alternate angle. Remember what I said about the corresponding angle, that they exist at the same side of the transversal line. They exist at the same side of the transversal line. So, but in the case of alternate angle, they exist at different sides of what? The transversal line. That's why you call it the alternate. They alternate. Okay. So now, what I call the alternate angle is the Z angle, or 2, as the case may be. You can do it this way. So this is how we design alternate angle. If I get that shape from here, if I get the shape from here, I believe you are following me, getting Z out of this, you can see this is what we have as Z. Okay, so having it in that form, there is a hand here and there is another hand here. So the arm of this one and the arm of this other one, we say they are what? Alternate to one another. You can see the arm here, the curve, and another curve. So, and they exist at different sides of the transversal line. So this one is alternate to this one. Okay, so we can say that C is alternate to F. C is alternate to F. Now let's look out for other. And once we have already spotted on that this one and this one are alternate to one another, therefore this and this are equally what? Alternate to one another. That's D is equal to E. D is equal to E. Now let's get the other ones. Here we have A above, okay, and we have this one below. You can see it from here, like the one we have here above here, below here. This B and G are alternate to one another. From our Z, you can see the pointer of our Z here then the pointer of our Z here. So where the arm faces, both of them are equal. You can see it here. We can now say that B is equal to G. You can see both of them are existing at different sides of the transversal line. This one is at this side, this one is at this side. So G is equal to what? B. G is equal to B, or B is equal to G. Both of them are alternates to one another. Of course, the remaining one, we can say that A and H are alternate to one another. H. So these are what we call the alternate angles. And as we know, alternate angles are equal. Now, vertically opposite angle is quite easy. Before we begin to take some examples, these are some of the background knowledge that we are drawing so that you'll be able to know how to solve the problems when they come. All right, so vertically opposite angle is quite easy. Vertically opposite angle is quite easy. Just like the name implies, opposite. Opposite means something that is facing each other. Okay, looking at it from here, A is being faced with D. Both of them are facing each other. So this one is vertically opposite to this one. Which one is facing B? C. So both of them are vertically opposite to each other. E is vertically opposite to H, and F is vertically opposite to what? G. So that's how we identify that. You can see this one is quite easy. A is equal to D. Then B is equal to C. We can go to the other one. C. Oh, we've gotten C already. Sorry. B, as we have here, is equal to C. Okay. C. No, we can't get C here because C is still the same as B. C is same as B. So we've gotten this. A equal to D. B equal to C. They are vertically opposite. Then we have to go to the other ones. That is to say, E is equal to what? Can you guess what it is? That's H. Is equal to H. Then G is equal to F. So that is what we call the vertically opposite angles. I hope you understand the background knowledge of vertically opposite angle before we begin to take some examples. You can move back and rewind the video, watch it again to understand it once more as we go into taking some examples. Yeah, we have an example here. That's the first example we have for today. Let's compare it with the knowledge that we got from the explanation on corresponding angle, alternate angle, and vertically opposite angles. Then looking at this, which angle can we say that compares to this one? Remember our popular Z. If I construct something like Z here, if I construct Z, you can see the joint of it here. You can see the joint of it here. What do we say the two angles are? That this angle is alternate to this one, right? So I can say that B is equal to what? 82 degree. Why? Because it's an alternate angle. Alternate angle. I hope this is quite clear from our video, from the explanation we gave on alternate angle. You get it that this is a transversal line. This angle is here from this our popular Z here. You can see the bottom, the joint of each of the Z as you have it like this. Each of the joints are said to be alternate to one another. All right, so that is why we said that B is equal to 82 because both of them are alternate angles, and we say that alternate angles are equal. So what can you say about A and B? A and B are said to be what? Vertically opposite angles, and we said that vertically opposite angles are equal. So, and we already know what B is. We know that B is what? 82. So therefore, vertically opposite angle, if this one is 82, that is to say A is equally what? 82. Therefore, we can say that A is equal to 82 degree. Or you compare it by corresponding angle. Because if we're talking about corresponding angle, and you draw something like 7 here, okay, you get something like 7 here. Above the hand is this, above the hand is this. So the above the hand existing at the same side of the transversal line. These two angles are said to be what? Corresponding angles. So you can solve it in many ways. to get your answer. So that is the answer to this particular question for the first transversal line. Now let's move to the second transversal line. Which one can we locate the answer easily? This from this transversal line, and if we get our popular F, out of this, you find out that we have below F. Okay, that's to say whatever that is here is same as E. Then above the hand and above the hand. So therefore 115 and D are the same. So from here I can say that D is equal to 115 degree. Wonderful. So we've gotten this place to be 115 degree. So can we now get any one of these? How do we get it? Because we can't compare this to this. So and even this one cannot be compared to this. Okay, so what we are going to do is that we are going to use the aspect of what angle on a straight line to get the value of either this one or this one. So does C and E have something in common? Look at it and tell me. Pause the video and get an answer to that, get a response to that. C and E, do they have any relationship, and what is the name? You can see E is at this side, C is at this side, so one can assume alternate angle, and that's exactly what it is. Because if we get our popular Z or F, as the case may be, if we get our Z or F, you construct it in this manner. You can see the hand here, then another hand here. So one can say that since you have the hand here, you have the hand here, so below and above are equal. So we call them alternate angles. We call both of them what? Alternate angles. So therefore, I can say that to compare this angle, we have to use the concept of angle on a straight line. Or we make use of this one to get angle on a straight line. If you recall, in our last video, we discussed angle on a straight line, and we said that angle that is formed on a straight line is said to be 180 degree. Any angle formed on a straight line give us 180 degrees. So we'll complete it here, this angle on this straight line. So therefore, when we say this plus this, that will give us what? 180. That's angle on a straight line. So to get that particular one, you can decide to get this one or this one. And we know that E and C are equal. So let's get this one. That will be C plus 115 is equal to 180 degree. So to solve for C, you have to collect like that. Then C is equal to 180 minus 115 degree. C is equal to 65 degree. So that is to say, C is 65 degree. So what can we say concerning C and E? We say that C is equal to E. What is the reason? Because they are alternate angles. They are alternate angles. Remember that the concept of what we did here is angle on a straight line. Angle on a straight line. Sorry, I'm writing it in abbreviation. Angle on a straight line. That's the reason for this one. So since we have our C to be 65 and we say that C and E are equal, therefore I can say that E is equally 65 degree. I believe you can see this one. This one's down here, cannot be seen. You can see to this level. Okay, so what we're talking about is to get angle E. We said that C and E are alternate angles. So I'll write it this way, that C is equal to E. And what is the reason? That is alternate angles. And we know that alternate angles are equal. And we have our C at 65 already. So therefore E is equal to 65 degree. So you can see we are done with the second transversal line. Let's move to the third transversal line. In the third transversal line, do we have any angle that we can compare to 92 degree here? Looking at this, we can get the corresponding angle. You can see the two hands, below the hand, below the hand. So this and this are corresponding to each other because they are existing at the same side. So therefore, I can say that H is equal to 92 degree. You know the reason? That's corresponding angles, and we know that corresponding angles are equal. So we have this place as 92 degree. So say if we know what's the relationship between F and H, can someone say that? That is vertically opposite angles. And we say that vertically opposite angles are equal. That is to say F is equal to H. And we know H to be 92. So therefore F will be sent in as 92 degree. And you know our reason here? That's vertically opposite angles. Vertically opposite angles are equal. So which other angle is remaining for us to find? So we found this place as 92 degree. So remaining G. Do we have anything to compare with any of these angles with G? Nothing. So we can use the concept of angle on a straight line. Angle on a straight line. An angle on a straight line is equal to 180. So we'll compare F and G. And we know our F to be 92 degree plus G is equal to 180 degree. You know the reason? The reason is angle on a straight line. Angle on a straight line equals 180 degree. So G, collecting light time, is equal to 180 minus 92 degree. So G will give us 88 degree. And that is the answer to these questions. In summary, we say that A is equal to 82 degree, B is equal to 82 degree, then C is equal to 65 degree, D is 115 degree, E is 65 degree, G, we got G to be 88 degree, we have F to be 92 degree, and do we have another one? The H is 92 degree. I hope this is quite clear. So that's all for this particular example. Let's get to the next example. Yeah, for the second example, here we have another question. This kind of question normally comes up for those in SS class, senior secondary. But of course, the junior category can still learn it for the sake of competitions and all that. All right, so to solve this question, we need to do a construction. We can see that these two lines are parallel to each other. Okay, and we have something here, and you're asked to find the value of x here. You're asked to find the value of x here. This is quite a simple question. So let's get it done. All we need to do is to construct, because we don't have a common transversal line between these two parallel lines. We don't have common transversal line. So what we do is that we create a straight line, construct a straight line from here. So let's do the construction. Construct a straight line. Construct a straight line. Let's call it MN. Construct this straight line. You can see that we now have three parallel lines. This line is parallel to this, is equally parallel to this. So let's compare between this line and this other one. They now have a common transversal line. So between this line, as we have it here, let me make it a bold line so that it will be easier for you to see clearly. Let's get it. All right, so from here, comparing between this line MN and the line AB, both of them are parallel to each other, and having this common transversal line. Can you still remember what we say concerning when we get something like Z out of it? So the joint here and the joint here are said to be alternate angles, right? So therefore, if this place is a straight, then this side should also be what? 63 degrees. So now let's compare this transversal line. The two parallel lines here, MN and ED. So they have a common transversal line like this. So that is to say, if this place is 47, this other side should also be what? 47. That means here is what? 47 degree. So you can say the value of x is the extension from here all the way to this place. Therefore, we can say that x is equal to 63 degree plus 47 degree. So what would that give us? 63, 47, 0, and 1, this is 7, that's 11. So that will give us 110 degree as our answer. I hope this one is quite clear. So this is where we're going to draw the curtain for today. So in our subsequent video, we're going to be discussing on angle of elevation and depression. Most importantly, you need to watch this video over and over again so that you'll be able to get familiar with some of these components of angles on parallel lines. That will help us in our subsequent videos. Thank you for listening and have a blessed day ahead.